So now the next question is also a very exciting one that talks about applications of differential calculus. Let's look at it very closely. It says to us here, after flying a short distance, an insect came to rest on a wall. All right. Thereafter, the insect started crawling on the wall. Okay, very exciting. The path that the insect crawled can be described by this model. So we are being given a model that describes, right, the path that is mapped by this fly when it's crawling on this particular wall, where h is the height in centimeters above the floor and t is the time in minutes since the insect started crawling. Okay, great stuff. 8.1, question 8.1. Right. 8.1 is asking us, at what height above the floor did the insect start to crawl? All right, this is a very simple question, right? The key word that I see from this particular statement is the word start, right? So we're asking you at what height. So there's no confusion there that you're being asked to figure out the height. Now, the model that helps you to figure out the height at any given time is t minus 6 into negative 2t squared added with 3t minus 6. So this is the model that helps you to figure out the height at any given time, right? Now they're asking us the height at the beginning, right? At the beginning or initially, the initial height. Those are some of the words that the examiners sometimes use. So when you start, how much time has passed when you're starting, right? No time has passed. Therefore, at the beginning, because they just said when it starts, right? At that point, it means the time that has passed is simply 0 minutes. No time has passed. So in order for us to find a solution to this problem, we just need to substitute our h, our t as 0. So we're looking for h of 0. That's going to be 0 less 6. And then negative 2 times 0 squared plus 3 times 0 minus 6. So I think you guys will agree with me that all the zeros will disappear. You're just sitting with negative 6 times negative 6, which gives you a value of 32 meters. So when this fly started crawling, it was at a height of 32, not meters, but 32 centimeters. The examiner said your height is measured in centimeters. Be careful of the unit that you're working with. They said height is in centimeters, so this thing definitely in the beginning, it was 32 centimeters above the floor. 8.2. How many times did the insect reach the floor? Okay, keywords again, right? How many times, right? We're asking how frequent did this thing reach the floor. Now, if you're asking me for time, if you're asking me for times, right, you've got to give me the height somewhere. There's somewhere where you have to give me the height. Now, think about this question. Think about it very carefully, right? We're only dealing with two variables, height versus time. If you're asking for height, you must give me time. If you're asking for time, you must give me height. That's how it goes, right? So in this question, they're asking us how many times. So we're looking for time, right? This insect will reach the floor. Now think about it. What's the height at the floor? Remember, it started from 32 meters. Then it's going to keep crawling. We don't know how it's traveling. I'm looking at this equation. It looks like a cubic, so we know that it's going to form a shape of a cubic graph, right? But the point is, on the floor, the height is definitely going to be, it's going to be 0, right? So let's go to our model. We're going to use a model that explains height, right? This model explains height as a function of time, okay? According to this, height is basically t less 6 into negative 2t squared plus 3t minus 6. Okay, now from this model, they said on the floor. On the floor, the height is definitely 0. So we're just simply going to try and solve for t, okay? So we have what we are looking at right now. Very beautiful indeed. So we're gonna, of course, we've got two things being multiplied, or two factors in this case. If two factors are multiplied, then the answer happens to be 0. The zero factor law says either the first factor is 0 or the second factor, negative 2t squared plus 3t minus 6 is equal to 0, right? Now that means when t was 6, this fly did manage in fact to get to the floor. Now we're going to try and find the t's here for this particular quadratic equation, right? Now I feel like this quadratic, you're going to have to try and use the quadratic formula to try and figure out what the answer is going to be. So negative b plus minus the square root of b squared minus 4ac all over 2a. We are motivated by the fact that we're trying to solve for t. Absolutely exciting stuff. You've got 3 squared here, less 4 by negative 2 by negative 6, okay, where everything is divided by 2 times negative 2. Now, you're going to try and figure out what is inside the radical sign, right? Let's find the number of that. That's actually 9. I see 9. Okay, so I see 3 squared, which is obviously 9, minus what I see here is basically 4 times 6 times 2. 4 times 2 times 6, which is going to be a big number. Remember, negative times positive times another negative is eventually going to become a negative. That's why I only have that one minus. We're getting negative 39. So negative 39 divided by negative 4. Now, at this point here, we're only noticing that we're not going to get an answer from this because the square root of a negative is giving you a non-real solution. So please stop. Most of you type this in your calculator. You guys typing this thing in a calculator. Your calculator says error, and then you're submitting the answer error to us. That's a flaw. Please don't do that. Please don't do that, right? There are only 2 things that can go wrong. If you divide by 0, it's undefined. There's no definition for that. But if you're looking for the square root of a negative, then it's non-real. Those are 2 different things. Stop saying everything is undefined just because your calculator is not giving you an answer, right? Be careful of that. So this one is not a situation of undefined. You will only get undefined stuff if you have anything, right, divided by 0. This is where you will tell us about things being undefined. But in this case, we have what we call non-real solutions, right? So the number of times that this fly will basically get to the floor is only once, according to my question. It's going to happen only once. So I'm going to say this will happen once as my submission to this because the second factor is not giving us a solution. Absolutely exciting. Okay, so I think we did answer that question. How many times did the insect reach the floor? The insect reached the floor once. The last question says, determine the maximum height that the insect reached above the floor. So we're interested in finding the highest point that this insect actually reached. Now remember, at the highest point, the insect is neither increasing nor decreasing. Think about it, guys. Let's think about it. We're looking for the maximum height, right? This insect is probably crawling, going up, and then it must come down. Because if we're saying it's going to reach maximum height, which means it's going to get somewhere and stop, and then come back. So that is basically as good as saying we're asking you to find the turning point of the graph that you're currently looking at. But the key thing here is at the maximum point, the graph is neither increasing nor decreasing. So it has a gradient of 0, and the gradient is the derivative. So what we're simply going to do here is take this word into consideration. They are saying maximum. So we know for a fact that for maximum, right? Please keep that in mind. For maximum, the graph is neither increasing nor decreasing. So the model, right, for that particular model, we're going to definitely try and find the derivative and equate the derivative to 0 because this graph, this particular insect will neither be going up nor down. So the rate of change of its height will just simply be equal to 0. So maximum is a very, very important word, particularly in calculus. If you want to figure out maximum stuff or minimum stuff, you need to know that the derivative at those points is always equal to 0. Very powerful. So now I'm going to get back my model. Let's get back the model again. So the model for 8.3, which is the formula that describes height, is given by h of t equals to t minus 6. Okay, that's basically the first thing that we have. Let's go back and make sure we're copying it correctly. Negative 2t squared plus 3t, negative 2t squared plus 3t, and then the last thing obviously here is minus 6. So this is actually the formula that helps us to figure out the height. Now I want to derive this thing. I can't find the derivative of this. Remember, we just said for maximum, we have to definitely find the derivative and equate it to 0 because the rate of change of height is 0 at any maximum point or any minimum point. So we're going to need to break these brackets first. So let's multiply. We're going to have negative 2t cubed. And then this is me multiplying by t, by the way, beautiful people. I'm going to get this one there, Now I'm going there, okay? I'll get positive 3t squared, and then this is going to be negative 6t. Now I'm going to come with 6, negative 6. It's going to be positive 12t squared, and then I'm going to get negative 18t, and then I'm going to get plus 32 at the end. So find what we call friends, aka like terms. Negative 2t cubed is a loner. And if you look closely, you'll agree with me that this guy and that guy are friends. You add 3 and 12, you're going to get 15, right? You're going to get plus 15t squared, and then you're going to get minus 18 and 6 are friends. This is actually going to give you 24t, and we're adding 32 on this. This is basically the expanded version of this particular model. Negative 2t cubed, and then you're going to get plus 3t squared, and then minus 6t, positive, negative 18t, and then plus 32. And then if you add the like terms, 12 and 3 give you 15, and then 6 and 18 give you exactly 24t. Now let's find the derivative of this. We get negative 6t squared. You're going to get 30t, and you're going to get minus 24, because when you're deriving, it's exponent times coefficient, exponent minus 1. 2 times 15, 2 minus 1. 1 times 24, 1 minus 1. The derivative of a constant is always equal to 0. Now, after doing that, we're just going to have to equate the derivative to 0 and have fun with what you guys are looking at right now. Okay, and I feel like negative 6 can go in all these numbers. Let's try to divide all of them by negative 6. 0 over negative 6 is 0. Negative 6 over negative 6 gives you t squared. 30 over negative 6 is going to give you negative 5t, and this one is going to give us a 4. Right. Negative divided by negative will give us a positive. Now we have to factorize this. You're going to get 2 factors. Factors of t squared is t times t. Factors of 4 is 4 and 1. Why? Because 4 plus 1 will reproduce my 5. Now they need to both be negative, because negative times negative will give you positive 4, but minus 4, negative 4 minus 1 will give you negative 5. Right, very important. Therefore, t is equals to 4, or t is equals to 1. Now we need to check which one of these two x values will give us maximum height. So in order to do that, you just substitute in your model. Find out, when the time was 4 minutes, what was the height? Right? So I'm going to call back my machine, a calculator. Remember, it's an instrument. Use it, use it. Okay, so we've got negative 2. I'm going to have a negative 2 open bracket. Now my t is 4. I'm substituting 4 there, right? I'm putting 4 close bracket. We need to put that to the power of 3. So I'm raising it to the power of 3. Remember, we need to add what? 15. And then I say I'm putting 4 here, 15 squared, right? Minus 24 times 4, close bracket, and then we've got a 32 at the end. It is giving you an answer of 48 if your math is actually done correctly, right? Just substituting this, and then you end up with an answer of exactly 48. So the height was 48 centimeters at 4 minutes, right? At 4 minutes, it was 48. What about at 1? What about the height when the time was 1? Okay, let's go back to the calculator, and now we are replacing all the 4s. We're going to call them 1s. So this is a 4. You can just press the backspace button, right? If you press the backspace, and then you replace that with 1, and then you close the bracket, right? Okay, backspace. Then I'm going to go find the other 4, all the 4s. I want to find all the 4s and replace them with 1. Backspace, okay, and then put 1 here. Right, go back. There's another 4, our last 4, okay, backspace, and then replace with 1. Then you press the equality sign, you're getting an answer of 21. Right, I'm getting 21 here. So which one is definitely the highest? Well, the examiner was asking the highest height. The highest height will be 48 centimeters when the time is 4 seconds. Let's check and make sure that we're doing the right thing. Find the maximum height that can be reached by this particular insect. So therefore, the maximum height is 48 centimeters. Very, very powerful. Okay, I hope you understood how to handle a question such as this one. This is basically a direct question that talks about the applications of differential calculus. We're using derivative to try and maximize or to optimize. We're coming back with a lot of very exciting content. Don't go anywhere. We'll be right back.